Hello students, welcome back to the next physics class. This video is part 6 on motion in a plane. Now let us see the content of this video. Angular displacement, angular velocity, angular acceleration, uniform circular motion and centripetal acceleration. Now we'll see what is angular displacement. Look at the definition students. Angular displacement of the object moving around a circular path is defined as the angle traced out by the radius vector at the center of the circular path in a given time. In a simpler manner, theta angle is equal to arc divided by radius. See here, look at the diagram. What is the arc here? That is S. Okay. So the distance between the 2 points P and P1 is called arc. So S divided by the radius is r. So what is the displacement? Angular displacement is theta. So theta equal to S divided by r. So here theta, the magnitude of angular displacement. The magnitude of angular displacement. It is expressed in radians. So that's all about the angular displacement. So what is angular displacement? Theta equal to arc divided by radius. Next we'll see about angular velocity. Fine. So look at the definition. Angular velocity of an object in circular motion is defined as the time rate of change of angular displacement. Okay. So what is velocity? Angular velocity in a circular motion? It is defined as the time rate of change of its angular displacement or rate of change of angular displacement. Okay. It is denoted by omega, right? Omega equal to angular displacement divided by time. So what is angular displacement? Theta, isn't it? So theta divided by t is known as omega or angular velocity. Fine. So you can mention this equation in terms of differentiation, that is d theta divided by dt. Okay, differentiation of theta with respect to time. So this manner also you can see, you can define the angular velocity. Next we'll discuss about what is angular acceleration. So let us see the definition students. Angular acceleration of an object in circular motion is defined as the time rate of change of its angular velocity. So just like your linear motions, circular motion we are discussing about angular displacement, angular velocity and angular acceleration, right? So in a simpler way, what is acceleration? In general form, acceleration is rate of change of velocity. Here we are talking about angular acceleration. So rate of change of angular velocity is known as angular acceleration. It is denoted by alpha, right? So alpha equal to angular velocity change, that is change of angular velocity divided by time taken, that is d omega divided by dt. Okay, d omega divided by dt is known as alpha, right? It is measured in radian per second square. So displacement is measured in terms of radian, okay, and radian per second is angular velocity and radian per second squared is angular acceleration. And so look at these three equations. So these are nothing but your equations of motion. So now we are going to write these equations in terms of angular, in terms of angle, right? So for uniform angular acceleration alpha, the equations of motion can be modified as, see, what is your first equation students? I'm writing here v equal to u plus at. Okay. So this is your first equation. So I'm going to replace this velocity as angular velocity. So how we will denote angular velocity? Yes, omega. Okay. So final velocity is u. So omega suffix f. Okay. So shall we name it as omega? F is nothing but your final angular velocity, and omega I is initial angular velocity, and alpha is nothing but your angular acceleration. And look at the second equation. So what is your second equation? V squared equal to u squared. This is your third equation, right? 2a, okay. So v squared equal to u squared plus 2a, clear? And how we can modify this equation? V as omega f and u as omega I, and a. So this term a as alpha, and s is nothing but displacement. So angular displacement is theta. Am I right? So we are going to replace as omega f squared equal to omega I squared plus 2 alpha theta. And what is your second equation? S equal to ut plus half at squared. Okay. So substitute s as theta and u as omega I and a as alpha. So you will get your second equation as theta equal to omega it plus half alpha t square. Okay, so this is about your angular acceleration, and we saw equations of motion in terms of angular acceleration, angular velocity, and angular displacement. Uniform circular motion. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. See, the word uniform refers to the speed which is uniform throughout the motion. Although the speed does not vary, the particle is accelerating because the velocity changes its direction at every point on the circular track. So look at the diagram, students. You can understand this statement very well. Okay, so the speed is not varying, but the particle is accelerating because the velocity changes its direction at every point on the circular track. So time taken by the object to complete one revolution on its circular path is called time period. Okay, the time taken by the object to complete one revolution on its circular path is called time period. For circular motion, the number of revolutions completed per unit time is known as frequency. It is denoted by small v. Okay, number of revolutions completed per unit time is known as frequency, small v. So what is the SI unit? Hertz. Okay, so unit of frequency is hertz. Then we'll see the relationship now. V equal to 1 by t. That is, frequency is the inverse of time period. So remember this relationship. It will be helpful for your numericals. And relationship between angular velocity, omega, frequency, v, and time period. Okay. So what is the relationship? Let us see. See, we know this relationship, right? Angular velocity omega equal to theta divided by t, where theta is angular displacement and t is your time period, right? And theta is equal to 2 pi. From the diagram you can see it is your circular path. Okay, so theta equal to 2 pi divided by t. So this is nothing but 2 pi into v. So 1 by t is nothing but v. So this is your relationship between angular velocity and frequency. Relationship between linear velocity and angular velocity. Fine. So linear velocity is denoted by v and angular velocity is denoted by omega. For example, the particle moving on a circular track of radius r is showing angular displacement del theta in del t time, and in this time period it covers a distance del s along the circular track. So imagine this. Okay. And what is your linear velocity? V is equal to r into del theta divided by del t. This is nothing but r into omega. You can understand this from the next table. See, angular velocity we know very well, omega equal to theta divided by t. So where theta is nothing but angular displacement and t is your time period. And look at this next column, v equal to s divided by t. So this is also very known equation, velocity equal to distance by time. Okay, so what is the distance here? So we know what is theta. Theta equal to s divided by r. So from this relationship we can write what is s. So s is equal to theta into r divided by time period. So replace this theta divided by t as omega. So what is v? V equal to r into omega. So this is the relation between linear velocity and angular velocity. Okay, so this is your last topic in this lesson, centripetal acceleration. The acceleration associated with uniform circular motion is called centripetal acceleration. To maintain a particle in its uniform circular motion, a radially inward acceleration should be continuously maintained. Okay, so I repeat the definition, students. The acceleration associated with uniform circular motion is called a centripetal acceleration. It is denoted by a suffix c. Okay, so a suffix c is equal to v squared divided by r. So what is v squared? Constant speed. Okay, and r is radius of the circular path. So v squared by r is nothing but centripetal acceleration. And we studied the relationship v, that is linear velocity v is equal to r into omega. Okay, so this is the relation between linear velocity and angular velocity. So we are going to write centripetal acceleration in terms of angular velocity omega. So substitute v equal to r omega here. So what is v squared? R omega the whole squared divided by r. Okay, so here also divided by r. So this r will get cancelled and you have r omega squared. Fine. So this is your centripetal acceleration. Okay, what we discussed in this video, we discussed about uniform circular motion, angular displacement, angular velocity, angular acceleration, and time period, frequency, relationship between time period and frequency, and relation among angular velocity, frequency, and time period, relation between linear velocity and angular velocity, and finally we discussed about what is centripetal acceleration. Fine, and go through your ebook for your better understanding. Thank you.